everyone. My name is Hua Cai. I hope you're having a great time during the orientation week. I know it's in general very overwhelming. You're receiving a lot of information, but trust me, it's okay. You'll be fine. You're all smart because you're sitting here, right? All right. So my research group is called uSMART, Urban Sustainability Modeling and Analysis Research Team. So basically, you see two things here. We do urban sustainability and we do modeling. Okay, so why is that? A little bit about myself. I'm an assistant professor with a joint appointment in industrial engineering and environmental and ecological engineering. So basically, I use IE tools, but I have environmental lenses. I want to solve environmental problems. Sustainability, especially urban sustainability, is what drives me go to work every day and wake up, right? So I did my undergrad in China and the master in the US. I worked in the industry in engineering consulting for 4 years and then decided to do my PhD, and then I'm here. So if you have questions, want to talk to someone who have some industry experience and want later go to academia, if you're thinking about should I do my PhD, should I do my, get some work experience, you could talk to me and I can share my experience with you. All right, so about my research, some of you might think, okay, what has industrial engineering to do with sustainability? Okay, industrial engineer is very good at optimize a system. It could be a production system, it could be a layout of a store, but we're very good at make one system very efficient, right? This is kind of like looking at one dot in the system. But if you look at the life cycle of a system, let's say, okay, we have a car, we can optimize the manufacturing of the car, right? But, to make the car, we need materials that's extracted somewhere around the world. It needs to be transported to this location, and it has multiple parts need to be assembled together, right? So if you look at the upstream and the downstream of making the car, then we're talking about a life cycle perspective. There are multiple systems connected that we need to optimize, right? This is only look at, upstream and downstream. And if you look cross-bound, people buy a car not because people want to drive. People want to go from point A to point B. And where you want to go, it's linked to how the city is designed. Where are the different point of interests around the city, right? Where are the mobility needs? So in the end, everything in the system is connected, right? The urban system is very complex, but we have the knowledge, we have the tools, we can make the system better, we can make the urban design better so it's more efficient, and when it's more efficient, you save energy, you reduce emission. That is the link I see between IE and the sustainability. So more specifically, I'm interested in improving urban sustainability while not satisfying any of the travel demands. We're not saying, okay, to save emission, everybody stay home. Don't go anywhere, don't go to movies, It's not about, changing what you need to do, right? But how do we do this more efficiently? And the tool I use is in general optimization, network analysis, simulation, especially agent-based models, system dynamics, life cycle modeling. Which model I use, which tool I use, depends on the problem. Environmental problem is very interdisciplinary. Different problem require different tools, and we choose the best tool to solve the problem. So just to tell you a little bit more about specific projects we worked on. So one project we look on is the environmental impacts of new mobility. The transportation sector consumes about 1/3 of the energies in the world, especially the liquid gasoline, liquid fuel, right? 90% of the gasoline is fed into the cars. So how do we make the system more efficient? And also, if some of you might already use Lyft, Uber, there are a bunch of new systems emerging, right? Bike shares in Chicago or on campus. How are those systems contribute to having the how do we travel in a city to be more sustainable? How do we design the system much better? Where do we locate the shared bikes? How many should we put there? How do we rebalance them when they migrated into the suburban area? What is the best way to do that? So there are a lot of interesting questions we need to answer there. And how do we solve the problem? One example is we use large-scale data sets. So this shows you animation of taxi trajectories in Beijing in China. You can see the yellow dots are the taxis and the green lines are the roads. Now it's about 5 a.m. and you can kind of see the city wake up and the streets become busier and taxis are going to the right corner of the city, and that is the Beijing International Airport. So we use this type of trip data or trajectory data, trying to understand what is the travel pattern in the city and how do we design the system to reduce the emissions but satisfy people's mobility needs. So other types of data we use include also maybe bike share trip data, right, etc. So large-scale data sets with millions of trips. And one more example of our projects is we also understand why do people make decisions on what you do, right? Why do you choose to buy USDA organic certified product? Or why do you choose to bike instead of driving? So we're interested in what are the things that change people's mind, or when you make a decision, what are you thinking about? So one project is we use the eye tracking glasses and trying to document how people evaluate information on different products in the store when they try to decide whether I'm going to buy the cheap product or buy better quality, more sustainable products. And also, different packages lead to the waste. So the decision we make at the point of buying something actually have a lot of signals sending upstream and impacts sending downstream. All right. So another direction of research we work on is the Internet of Things. Nowadays, everything is connected. There are smart homes, smart buildings, tons of sensors are collecting information about our city and how we do things, right? The vehicles, I showed you earlier in the data, you can see them as sensors in the city that sensing where people want to go. There are also a lot of room temperature sensors, all kinds of sensors. How do we integrate different data from those sensors and improve our urban system is another question we're looking at. So it just gave you a very broad range of the things we look on. So any questions so far? If you're interested in want to work with me on some of the projects. So number one, we do a lot of modeling. We do a lot of data analysis. So I don't require you to already know the tools to work with me, right? So what I do care about is that you are interested in the topic, because I believe if you're interested in something, you're going to do great because you have the internal drivers, right? So you need to be interested in the topic, and you need to be curious, right? When you're curious, you can learn anything, and you're self-motivated. Self-motivated people can learn anything about very fast, right? So if you have those three things and you want to work with me, how does that work? We normally do an independent study, and we can discuss the project. If you want to work with some data, do some coding, to do some modeling, we can send me an email and we can chat about it. All right, so that is what I want to share with you, and I think we're about at time. So do you have any questions that you just want to get up? Yeah?
So the research topic of industrial ecology, is it related to how waste from one industry is utilized in another industry, that kind of activity, or is it more urban society related?
So the question is industrial ecology related of feeding waste from one industry to another industry? And that is part of industrial ecology in general area. So that is not something I specifically focus on, but it is part of my research interest. Yeah. Yes?
Yeah, there was a design for a decision making. So it is basically, it differs from each people, right?
Uh-huh.
One may worry about the cost, but one may worry about the quality, right?
Right. Exactly. So he's asking about the decision-making project. Right. So everybody may have different decision-making process. That is true. You may care about the health attributes of a product and look at the nutrition table, and I may care about the price and buy whatever the cheapest, right? There are different individual differences. What we want to find out is what are the relationship. Does income level, education level has anything to do with it? Does having kids has anything to do with it? What is the distribution of different people in different groups? How can we cluster people with different decision-making behaviors? Yeah. You can. Yeah, you go.
To what extent do you, some of these seem like more interdisciplinary than, than others. Do you find yourself often wanting to leverage models or major concepts from other fields? And when you do, is it ever difficult, or do you ever have to sort of go out of your way to try and validate those in a way that holds up in an industrial engineering standpoint, rather than say, you might want psychology, stuff, so different sort of standards of validity?
Yeah, definitely. Depend on the project. So based on the needs of the project, we collaborate with other people who has better expertise. For example, on this project, we collaborate with a professor from Cranard who has better background in consumer science, right? So they can refer us to, there are some existing models in evaluating some of the product attributes, and we could leverage on those models. And for example, for this project, we'll also work with Mark Lechtel, who is also a professor here in IE, who has expertise on human factors, right? How do you alert people using safety labels, etc. So we do work with people with different expertise and leverage standing on the shoulder of the giants. Do you have a question?
Yeah, so with the decision-making of the sustainable consumptions, do you manipulate things like product design and location of certain things, or switching price, like not necessarily using existing products, but maybe just like changing different aspects to see if that influences people's outcomes towards making a decision for a more sustainable, healthier product?
Yeah, we're entering that stage right now. So before we're collecting naturalistic behavior data, we just tell people in general we want to understand your behavior, but we don't try to change anything, right? We don't control what you buy. We don't control how long you stay in the shop. We don't feed you any information. So now we have enough background data. Now we want to kind of, maybe change the label of, where are the price, or, present you a video of some information, education materials, and see if some of those will change people's behavior. So we're designing the experiments right now. That's a very good question.